Standard deviation from the mean. The standard deviation is the most useful and frequently used measure of dispersal because it takes into account all the data. Find the standard deviation of the following data: 11, 13, 17, 19, 23, and 25. So let's get the mean. We have mean, which we call x bar, is equals to the sum of all the scores divided by the number of scores. So this will be equal to 11 plus 13 plus 17 plus 19 plus 23 plus 25 divided by 6. So this gives us 108 divided by 6, which is equals to 18. So the mean here is equals to 18. I now construct a table. So in this column, I calculate what we call the deviation. Deviation is the score minus the mean. So here I shall have 11 minus 18, which gives us minus 7, 13 minus 18, which gives me minus 5, 17 minus 18 gives me minus 1, 19 minus 18 gives me 1, 23 minus 18 gives me 5, 25 minus 18 gives me 7. The next parameter we have to calculate is the square. So we calculate the square of the deviation from x. So we get this called as d square, which is equals to score minus the mean all square. So I'll square this, which gives me 49, 25, 1, 1, 25, 49. Summation of this deviation gives us 180. So now we get our standard deviation from variance. So variance is equals to the sum of this deviation divided by total number of scores. So we can say the sum of d square divided by the sum of x. The standard deviation is the square root of variance. So we shall have the standard deviation is equals to square root of the sum of the deviations divided by n. So standard deviation is equals to the sum of the deviations all square divided by n all to the root. So in this our case, we shall have standard deviation will be equals to 180 divided by 6 square root. Square root of 180 divided by 6. Summation of the deviation all square gives us 150. 150 divided by 6 all to the root. So this is equals to square root of 25. So our standard deviation is equals to 5. Let's say we are given this data that has been summarized in the frequency table to find the standard deviation. So we start by calculating the mean. So the mean, which we call x bar, is equal to the summation of the product of score and frequency divided by the summation of the frequency, which is the same as summation of the product of the score and frequency divided by n, because summation of frequency is equals to the number of scores. So this will give us 9,240 divided by 60, which gives 154 centimeters. So now, how do we get our standard deviation? We start by constructing another table where we shall have the deviations from the mean. So here, we shall look at the deviation from the mean. So we call this D, which is actually score minus the mean. So our mean there is 154. So 140 minus 154 gives us minus 14. 145 minus 154 gives us minus 9. 148 minus 154 gives us minus 6. 150 minus 154 gives us minus 4. 155 minus 154 gives us 1. 156 minus 154 gives us 2. 158 minus 154 gives us 4. 162 minus 154 gives us 8. 165 minus 154 gives us 11. 170 minus 154 gives us 60. So we need to calculate the square of this deviation. So here, d square, which is actually x minus x bar all square. So let's square this. What is minus 14 square? This gives us 196. So here I'll have 81, 36, 16, 1, 4, 16, 64, 121, 256. So this is our deviations. But remember that these scores reoccur in the data from our frequency table. So I have to include here for frequency. So what are the frequencies? We have 2, 3, 5, 11, 15, 10, 8, 3, 2, 1. So what is the product of frequency and the square of this deviation? So now we shall have this times this, which gives us 392. 81 times 3 gives us 243. 36 times 5 gives us 180. 16 times 11 gives us 176. 1 times 15, 15. 4 times 10, 40. 16 times 8, 128. 3 times 64 times 3 gives us 192. 21 times 2, 121 times 3, 121 times 2 gives us 242. 256 times 1 gives us 256. So now, what is the summation of these frequencies? It will be equals to 60. There are 60 entries in that data. So we'll look here for the summation of the product between frequency and variance and deviation squared. So this is equal to 1864. So we can see from here that our variance will be equals to the sum of the product between f and deviation square divided by the sum of the frequencies. So I'm saying there that standard deviation will be equals to square root of the sum of product between f and d square divided by the sum of f. So this is equal to square root of 186 square root of 1864 divided by 60. So this will be equal to, punch that on the calculator, we shall have 5.57. So we have come out with the standard deviation of this data. So we could calculate the standard deviation of the data in the frequency table by using a working mean or an assumed mean. So we don't need to calculate an exact mean, we can assume a mean and use it to calculate standard deviation. How do we go about this? So using the working mean or assumed mean of 155 centimeters, calculate the standard deviation. The working mean of 155, I look for the deviation from the mean, d, which is actually the score minus the assumed mean. So I shall have 140 minus 155 minus 15. 145 minus 155 gives me minus 10. 148 minus 155 gives me minus 7. 150 minus 155 gives me minus 5. 155 minus 155, 0. 156 minus 155 gives me 1. 158 minus 155 gives me 3. 162 minus 155 gives 7. 156 minus 155 gives 10. 170 minus 155 gives us 15. So the next thing, I square these deviations. So d squared, which is the score minus the assumed mean, all squared. So this will give me 225. This is 100. This is 49. This is 25. This is 0. It's 1, 9, 49, 100, 225. 225. So now let me include the frequencies. So I have 2, 3, 'So now let me include a column for the product between frequency and deviation. So this will be minus 15 times 2 gives me minus 30. Minus 10 times 3 minus 30. Minus 7 times 5 minus 35. Minus 5 times 11 minus 55. 0 times 15, 0. 1 times 10, 10. 3 times 8, 24. 7 times 3, 21. 10 times 2, 20. 15 times 1, 15. I include a column for the product between frequency and d square. So it will be this times frequency. So 225 times 2. So I have 450. This times this gives me 300. 49 times 5 gives me 245. 0 times 15 gives me 0. 25 times 11 gives me 265. 25 times 11 gives me 275. 0 times 15 gives me 0. 1 times 10 gives me 10. 9 times 8, 72. 49 times 3, 147. 100 times 2 gives me 200. 225 times 1 gives me 225. So now, what do I see here? I have the sum of the frequency is equal to 60. I have here the sum of the product between F and D is equal to minus 60, and the sum of the product between frequency and deviation square is equal to 1924. So we see here that summation of frequency, so number of scores, which is n, summation of frequency is equals to 60. The sum of the product between frequency and deviation is equal to minus 60. The sum of the product between frequency and deviation square is equals to 1924. So now our variance here, let's express this in variance. This will be equal to the sum of the product between frequency and deviation square divided by n minus the sum of the product between frequency and deviation, all divided by n all square. So our standard deviation will be equals to the sum of the product between frequency and deviation square divided by n minus the sum of the product between frequency and deviation divided by n all square to the root. To the root. So this will give us 1924 all over 60 minus 60 all over 60 all square. This is all to the root. So this will be equals to 32.067 minus 1 square root. So this is 31.067 square root, which is equal to 5.75. So we have had the standard deviation by using our assumed mean of 155. We are given this frequency table that contains group data. To find the standard deviation, what do we do? Here we are going to look for the mean. I shall start by looking for the mean. So here I roll up a table and I'll need to calculate the class center. How do I get the class center? I add the lower limit and the upper limit and divide by 2. So I take the average of the lower limit and the upper limit. This is 1 plus 5, which gives us 6 divided by 2. So here 3. I do that, I have 8, 13, 18, 23, 28, 33, 38. I recopy the frequencies. I'll need to look for the product between the class center and the frequency. This is 3 times 3, 9, 8 times 10, 80, 13 times 7, 91, 18 times 12, 216, 23 times 4, 92, 28 times 8, 224, 33 times 4, 132, 38 times 2, 76. What is the sum of the frequencies? Sum of the product between the class center and frequency gives us 920. The number of squares is the summation of the frequency. I'm looking for mean. Summation of the product between class center and frequency divided by the summation of frequency. This will give us 920 divided by 50, 18.4. I will use this exact mean of 18.4 to calculate our standard deviation. I need to come up with a new table. I need to get the deviation from the mean. How do I get deviation from the mean? I'll have class center minus the mean. The first value here, I'll have 3 minus 18.4. This gives me minus 15.4. So minus 10.4. Minus 5.4. Minus 0.4. 23 minus 18.5 gives 4.6, 9.6, 14.6, 19.6. To get d square, I have to square the deviations. Minus 15.4 square gives 237.16. This is 108.16, 29.16, 0.16, 21.16, 91.16, 213.16, 384.16. I recopy the frequencies. What is the product between the frequency and deviation square? Here I have 3 times 20, 3 times 237.16, 711.48, then 1081.6, 204.12, 1.92, 84.64, 737.28, 852.64, I need to get the sum of frequencies. What is the sum of the product between frequency and deviation square? Standard deviation is given by summation of product between frequency and deviation square divided by summation of frequency all to the root. This will give me 4442 divided by 50, then take square root. .43. This is the standard deviation for data given in a frequency table. For group data given in a frequency table.